Hi everyone, in this video we're picking up in 8.3 on trig integrals, and we're continuing on after our previous video about what I called number 1, which was having to do with powers of sines and cosines. Now I am skipping part 2 and I'm going to add that in with part 4 in the next video, so we're jumping right into part 3 where we have powers of tangent and secant. So secant and tangent are going to show up in our integrals and they're going to have exponents on them. So let me remind you of some stuff. So the identities that are going to come up in this section are the tangent squared identity, which is a modified version of our Pythagorean identity. So tangent squared is the same as secant squared x minus 1. And if we solve this for secant squared, we have secant squared x is tangent squared x plus 1. And then let me remind you also about some derivatives that are going to be useful to recall in this section. The derivative of tangent x is just secant squared x, and the derivative of secant x, if you recall what that was, is secant x times tangent x. Okay, so these things are going to come up in our work, and we're going to jump right into an example. So in the previous video we did a handful of examples. So I'm going to call this example 4, even though it's the first one in this video, just to kind of keep going in this section. So example 4, what we're going to jump into is integrating tangent to the 4th power of x dx. Alright, so now the steps are not always like 1, 2, 3, 4 in these types of problems, integrals with powers of tangent and secant. You kind of have to look at what you're working with. And so for this first example, I want to leave these identities here because I want you to see what we're going to end up working with. And so if we can rewrite our tangent to the 4th in terms of tangent squared, and then recall that the derivative of tangent has secant squared in it, we're going to be able to use a handful of what I have written here. And so let's start by saying that this is the same thing as tangent squared x times tangent squared x. Okay, and now why we wanted to rewrite that is because of what we have available to use. And so one of these tangent squareds, you can go ahead and substitute the fact that that equals secant squared x minus 1. And then once we do that, we can go ahead and use u substitution because the derivative of tangent has secant squared in it. Okay, so that's where we're headed with this, using things we've learned from the past. So let's go ahead and do that work. So we had just mentioned what we're going to end up doing with substitution. And so tangent squared is the same thing as secant squared x minus 1. And so let's start there. We're going to rewrite, and we have integral of tangent squared x times quantity secant squared x minus 1 dx. And then let's go ahead and distribute this out. So from here we have integral of tangent squared x times secant squared x, and then distribute the tangent over here to the back. So minus tangent squared x dx. Then what you can do here is we're going to actually separate this into two different integrals. But over here, this part, this is going to work out really well because if we realize the derivatives that we know, if we let u equal tangent of x, then the derivative of that choice is right here. So this is secant squared x dx. So we'll separate these into two separate integrals. And then over here, what we'll end up doing is we're going to use our identity again, like we just did. So this is secant squared x minus 1. Alright, so let's rewrite that. So I'm separating this into two different integrals. So this is u squared, and then all of this is going to be secant squared x. I'm going to put the dx here, so du, and then minus this integral, so minus secant squared x minus 1 dx. Alright, and now how is this any better? Well, it's better because we know this one. We know this integral. It's whose derivative is secant squared. Well, we know that, it's tangent. So we can keep going. So we're going to integrate from here, and then we'll be done with this example. So I'm going to leave this here, but then I'm going to erase this part. Okay, so now we're ready to integrate. In our first term, we know that this is going to be u cubed over 3. Over here, this is going to be minus integral of secant squared is tangent, so minus tangent x. And then minus integral of -1, so minus and minus is plus, integral of 1 is just x. And I left this here so we knew what u was, so this is now tangent cubed x over 3 minus tangent x plus c, because there was no limits of integration. Final answer, this is the value of this integral here. Moving right along into our next example, example 5, integrate secant cubed x dx. So this one's a little bit tricky, and I'm going to show you how to do it, but if you were to work this out on your own before I show you, you might try u substitution or using the trig identities that we talked about already right away, but they're not going to work out. So let me show you how I'm going to rewrite this. I'm going to rewrite this first as the integral of secant x times secant squared x dx. Okay, so here's what I was just talking about. Let's say I let this, and this is, I'm going to erase this because I'm not going to keep going forward with what I'm talking about here. Let's say I let this be tangent squared x plus 1. Well, in that, if I do that, then my next step after that would be to let u equal something. So then, just think about it. If u was tangent x, well, the derivative of this is secant squared, but we don't have that because we substituted it out. So that's not going to work. Okay, well, what if I tried back here? Maybe I could try u sub at the beginning. Maybe secant x is u at the beginning of this. Well, the derivative of secant x is secant times tangent, and there's no other tangent here. Okay, now even if we were to substitute tangent squared x plus 1, it's tangent squared instead of just regular tangent, which, let me just write what I'm saying. The derivative of secant is secant x times tangent x. So I know this looks sloppy, but it's because I'm showing you this is not going to work. This derivative, even if I left this tangent squared, I'd have an extra tangent there. So none of that's going to work. And so what's actually going to work is integration by parts. Okay, so you might not have thought about that at the beginning, but this is the process we're going to use for this example. So integration by parts, let me remind you of how that looks. If you have the integral of u dv, you can rewrite this as u times v minus the integral of v du. So this is what we're going to do. And so in our case, well, always you pick u and then you find du, and then you pick dv and you find v. So for us, let's kind of think about it for a second. The way I separated it is going to help. Secant squared was already a derivative. It's a derivative of tangent. So that's going to be a good choice for dv because that's a derivative already. So I'm going to start there. I'm going to say that secant squared x dx is dv, meaning that what's left over here is u, secant x. All right, now let's fill in what we know. Derivative of secant x, didn't leave myself a lot of room here, is secant x times tangent x. Okay, and we just said it, if you integrate secant squared x, that's just tangent x. So there's our values, and we're going to go ahead and plug them in. So we're integrating this left side integral, which is essentially, if we go back, secant cubed x. But we're filling it in by using the right side of the formula. So I'm going to jump right into u times v, secant x times tangent x, minus the integral of v, tangent x, du, which is all this over here, secant x times tangent x dx. Okay, so this we don't have to worry about. We're not integrating. It's already just part of our answer. But let's see what's happening here. So let's rewrite this part. And I won't write everything. I'll just focus on this integral here. So this is going to be the integral of tangent squared x times secant x dx. If we rewrite tangent squared in terms of secant squared, we're going to end up with a secant cubed again, but that's actually where we're going to want to go, and I'll try to explain why. If you try to use u substitution again here, it's the same thing we started with. It's not going to work because if we pick u to be tangent, derivative of tangent is not there. We need a secant squared. If you pick u to be secant, derivative needs secant and tangent, which is not there either. And so what we're going to do right here is we're going to rewrite this in terms of secant from our trig identity. So this is secant squared x minus 1. And we're going to actually put it together with what we have on the left side of the equal sign. So this is kind of an interesting technique, but I'll show you how this goes. So let's just make this look a little better, and then I'll move up. So this is secant cubed x minus secant x. Alright, now this part here, I'm going to show you that we already are working with this, so we're going to actually move this term over. So let me put it together, I'll move this up and make this look a little better. So I had what we just worked on, I just moved it up here, and reminding you of our integration by parts formula. So what we were working on initially was this secant cubed x integral that we had here. And so even though we came up with it again, that's okay because we're using this method of integration by parts. We can actually move this integral over. So this integral of secant cubed x, and technically there's a dx here if I separate these, which I will, I'm going to move it over here. So I'm going to move it, add it to both sides, therefore moving it over to the left side. And so what we end up with here is 2 integral of secant cubed x dx. And then on the right side we have secant x tangent x from right here. And then let me put this together better. This was negative times a negative, so that's positive. And I still was integrating this term, so integral of secant x dx. Alright, and so what's left, this last integral, we actually know this one. And this is one of the ones that was on our table 8.1 from a previous section. And it's one that it would be good to kind of know this one by memory. And I'm not a big proponent for memorizing, but this is one that it's a little harder to derive, but if you know it, it's fast. So this now becomes secant x tangent x, and then this integral is the natural log of secant x plus tangent x. Now this is not our answer, and here's why. This was twice the integral we were actually looking for. So this is still 2 of what we were initially trying to find, 2 times it. So really the last thing we need to do here is just divide by 2. And so it's our same answer with like a 1/2 in the front. So just to save some writing, we'll just go like this. Our answer, so the left side is now exactly the integral we were looking for. Integral of secant cubed x dx equals secant x times tangent x plus ln of secant x plus tangent x all over 2, and then plus c. Alright, so let's box that in, and that would be the answer for this integral. It's a little weird on this one, but sometimes you'll try u substitution like I was trying to show you when it didn't work, and then you'll realize you need something like integration by parts, and then this type of method where we move over the same integral to the other side. Alright, last example for this video. So example 6 says, find the integral of tangent to the 4th power of x times secant to the 4th power of x. Okay, so let's just try some stuff, and sometimes you'll just see, okay, how can I rewrite these terms? And let's start with breaking apart the secant, because we know secant squared is the derivative of tangent. So if we have tangent to the 4th of x is being multiplied by secant squared x times another secant squared x. Alright, I want to show you something here before we keep going. let's say we tried u substitution right now. If we let, and you don't have to write this because I'm going to do something different. Let's say you let u equal tangent right now. Well, the derivative is definitely secant squared. However, you have an extra secant squared. So u substitution at this point, the way this is written, is not going to work. So we're not going to do that. We are going to keep rewriting. And so what we're going to do here then is deal with one of these extra secant squareds, because if we have two, that we just saw that substitution won't work. So one of these secant squareds, we're going to rewrite it as tangent squared x plus 1. Okay, so let's just simplify this a tad. So we have, let's go ahead and distribute this tangent to the fourth. So this becomes tangent to the 6th x plus tangent to the 4th of x. Okay, still times this secant in the back, secant squared, excuse me. And then now let's distribute that secant squared. So this is integral of tangent to the 6x times secant squared of x plus tangent of x to the 4th times secant squared of x. Alright, now why this mattered and why this helped. Now we can separate this into two separate integrals, and I'll just do it in another color. If I go ahead and throw my integral sign on there and add a dx here, now we can use u substitution and it is going to work. In the first integral, if we let u equal tangent x, well, we only have a single secant squared dx, so that's going to be doable this time. And then, sorry, dx. Very much the same thing back here. U is tangent x, and so du, same exact thing, is secant squared x dx. Alright, so this is much better because we separated this, the two secant squareds that we had at the beginning. So now we have, in our first integral, u to the 6th du. Second integral, this is u to the 4th du. And then we can just integrate. This is u to the 7th over 7 plus u to the 5th over 5. And put u back in. It was tangent for both of these. So this is tangent to the 7th x over 7 plus tangent to the 5th x over 5 plus c. And there we have it.